Good morning, everyone. So today, as I said before, we will have a lecture. We will talk about the reflection of the light, and then uh, I will try to have a very short lecture. Then we will just see all that I will be explaining in the lab today. Okay, so reflection. We already talked about the light, and then we said that the light it has a spectrum of a radio wave to gamma ray, X-ray, and then we just try to focus more on visible light. We already talked about the opaque material, and if you remember, what was the opaque material? The opaque material try to block the light, and it doesn't let the light to transfer through the material. But we have a transparent material which let the light to pass through the material, like a glass. Okay, opaque material, like the bulb. So if we have a light, definitely this light in the inside the room doesn't go into the home. So we had a opaque material absorb the visible light, and the transparent material will pass the light through itself. So we have some material, instead of absorbing and transferring light, they will be reflecting light. So, and we call it the reflection of a visible light. And the reflection is not just for visible light. It can happen for radio wave, for uh, gamma ray, X-ray, and any other electromagnetism wave or light that we know. So, for reflection, we have a principle of a least. So, principle of the least time. What does it mean? Light take the path that require the least time when it goes from one place to another place. So what does it mean? It means that the light will always try to find the closest pathway to go from one point to another point. Okay, let's say we have point A and point B. Okay, based on this principle. So the light will travel like this, or like this. Which one? A straight line. Always try to require the least time when it goes from one point to another point. Why? Why pathway number one is and two is not our answer? Because it takes more time to go from A and to B from in the pathway number one and pathway number two. But the least time is from pathway number three. Okay? So it means that we already know that the light is a wave. So this wave, it's travel through this straight line. Okay, so that's why we just say the light always travel through the straight line. Okay, so when we have a light, the light will always travel through the straight line. By knowing the principle of the least time, we would be able to explain the law of reflection. So, what is the law of reflection? The shortest distance can be determined by drawing a line from point A to an artificial point B is kind of law of reflection. What does it mean? Let's say we have a surface, instead of absorbing and transferring the light, it will be reflecting the light. So we would like to see in which direction the reflected light, will go. Yes? So let's say, let me just open a new page. Okay. So as I said, we have this surface, yes? Let me just draw a straight one. Okay, so the light comes and reach to the surface, okay? So instead of being absorbed or passing, if it pass, it pass again through the straight line, yes? Okay, but it doesn't pass. It will reflect. So how it reflects, okay, again, the light always try to find the shortest pathway. So again, it doesn't go this way. It doesn't go that way, okay? So if the light would pass, this would be the line. But if it's being reflected, we will draw exactly the same line here. So let's say this is an incident, this is a reflected one. If you find any point on the transparent light, okay, let's say you call A, you just draw the same distance of A. It is not the same distance, okay, but you assume that this is the same distance. A. If you just say this is a B, okay, so I just keep drawing these, okay, so you will have the B here, okay? So it means that these are called A prime and B prime. If the light would pass from this surface, good, it would go through the straight line. Because it's not being passed, okay, so what does it mean? It means that it's reflected. How it's reflected, you can just draw this dashed line, okay, and then find a couple of points here, any point, and then draw exactly the same point of A with the same distance. Let's say if this is the 1 centimeter, this should be 1 centimeter. This one is not accurate, okay? So if it is this centimeter, this is going to be one centimeter. 1 centimeter, 1 centimeter. 2 centimeter, 2 centimeter. 3 centimeter, 3 centimeter. And if you connect these points together, this will be the reflected. Okay? So when we analyze the reflected one, we will have these rules. Let me just open new page. So again, this is a surface which reflects the light, and we have incident light, incident light. So I define new line. I call this line normal line. What is this normal line? The normal line is the line which always perpendicular to the surface, to the plane surface. Good. Normal line is a line which is always perpendicular to the surface. Good. So I call this angle theta I. I call it angle of incident. Angle of. Good. And I said how I can draw the reflected one. I said if the light pass, now it doesn't pass. If this is A prime, okay, I just draw A prime here. Yep. If this is a B prime, I just draw a B here. Okay. When I connect these, this is going to be the reflected light. So I call it reflected light. And I call this angle theta r, or I call it angle of reflection. Based on the least principal time in the reflection, the theta I is equal to theta r. If your incident light is 30 degree, your reflected light will be exactly 30 degree. If your surface, the reflecting surface, is the plane surface. Okay? So we need to define a normal line. What is the normal? We always draw the normal line. The normal line is always perpendicular to the plane surface. We would be able, by having the normal line, we can find the angle of incident light. We find the angle between the normal line, the incident light, and whatever the angle is, the reflected is going to be the same angle. Okay, another example. So let's say we have a reflecting surface, and then this is a normal line, and I have a light source. Okay, so this is a light source, and the light reach to the surface, yes, with theta I of 30 degree. What would be the angle of reflection? Exactly 30 degree. Okay, so if we are drawing, we need to draw the angle, the reflected light, okay, in a straight line, yes, and these should be exactly 30 degree. This is called law of reflection. We will be using this law, okay, and to see how the image will be created on the reflective surface. Okay, any question? Back to this, yes. Okay, as you can see here, we have normal line. This is the incident light or incident ray. The angle between the incident light or incident ray is going to be a angle of incident, and the angle between reflected ray or reflected light and the normal line is going to be the angle of reflection, and the angle of incident is always equal to the angle of reflection. Then this, we call this law of reflection. What is the law of reflection? The angle of reflection is always equal to the angle of incident. One of the reflecting surface is a mirror, okay? Plane mirror. You definitely have, everyone have a plane mirror, okay? And in your home, and we would like to see, if you are standing in front of the mirror, okay, how this image is created by using the law of reflection. The reason that we are seeing the object or pictures, okay, is because of the light is reaching to our eyes, yes? So, and we would like to see, if we are standing in front of the mirror, how how the reflected light or reflected rays reach to our eyes. That's how we can see the image. I will explain here. Let's say you have a candle and is a kind of a light source, and we are placing this candle in front of the mirror. Good. So this light source radiate the light, good, in 3D everywhere in the space. Good. So what we do, we just select some of these light. Okay. So let's say this is the incident light. This is the incident light, and again, incident light. The purple arrow shows the incident light. Good. We can draw more incident light. It doesn't matter. You can draw just one, you can draw, 10. And we would like to see, let me just change the color, how the reflected light help us to see the image of this candle. What was the law of reflection? Incident light is angle of incident light is equal to angle of reflection. So for any incident light, I draw the normal line. See here? This is a normal line, yes? This is a normal line, yes? It should be perpendicular. What was the normal line? Normal line is perpendicular to the reflecting surface, which here is mirror. So, law of reflection says that the angle of incidence should be equal angle of reflection. Good? So, this was the incident light. This is the angle of incident. Yes? You see the angle of reflection is exactly equal to the angle of reflection. Yes? If it is 10 degree, the angle of reflection is going to be 10 degree. Okay? That's why we just draw the reflected light. Okay? So, what is the next one? This one. Good. What is the angle of incident for this one? Let me just call this one. Okay, these two. The ray number 2. What is the angle of incident? Perfect. 0. Okay? Because it's exactly in the direction of the normal line. Yes? Incident line and normal line are exactly in the same direction. The angle of incident is 0. So the angle of reflection should be 0. So what does it mean? It means that if we have the light which is perpendicular, the reflected light will be perpendicular as well. Yeah? See? Incident light, reflected. Again, the next one. I have already drawn the normal line. There is the angle of incidence, so we will have the angle of reflection. Yes? These two should be exactly the same. You cannot draw bigger. Okay, if it's 10 degree, you should draw 10 degree. If it's 20 degree, you should draw 20 degree. If it's 60 degree, you should draw the 60 degree. Yes, the angle, reflected line, the angle of the reflection, or we call it the angle of reflection. Okay, here, as you can see, the reflected light diverge. Okay, the reason that we see the light is because of the reflected light. But as you notice here, you see this reflected goes here. This reflected goes here, here, here. They never reach to each other. Okay? What we do, we just extend important. We will try to extend the reflected light behind the reflecting surface. So what I do, so this was the first reflected light, yes? I could draw, let me just use different color. So I just extend, see, this, good? This is already extended. I will extend this. I will extend this reflected line. I extend the last one. Again, you don't need to draw 4 incident light. If you draw 2, that's it. You would be able to find the intersection. As you can see, if you extend the reflected light, they will intersect at one point. What is that point? Focal point. No, no, not the focal. We will get to that point. This point is the point that the image of this light, okay, you remember this point is radiating a visible light, yes? We had incident light, we just put in front of the mirror, we draw the reflected light, and the reflected light, they converge behind the mirror. The intersection of these extended reflected light will give us the image of this candle. You can do the same thing for other part of the candle. It doesn't matter. Good? It doesn't mean that it should be a light source, okay? So if I stand in front of the mirror, definitely you will see my picture, yes? Am I radiating a visible light? No. I receive a light, yes? The light will be reflected to the mirror, and then there will be a reflection in the mirror. That's how my image will be created. Good? So the reason that we just use the candle example, it's because it's a kind of source of light, visible. So how the image is created, how the image is created in the plane mirror. So one more time. Again, we have a mirror. If I could draw a good mirror. This is a plane mirror. And you have object. Let's say this is object in front of the mirror. Good? So I pick one point of the object, top or bottom or middle, it doesn't matter. So which one I pick? I pick the top. Good? So I just have to draw 2 incident light. Okay? The reason that you see me, because you just see the reflected light from me, yes? Okay? I am a kind of radiating a visible light. That's why you can see me. Any object, the same thing. Is a kind of a source, light source, a visible light source. So I just pick this part. So I just draw 2 incident light. So what I do, I draw the one which is perpendicular. Good. Okay. And then I draw one which passing this way. Okay. You can draw more incident light. So what I need to do, I need to draw the reflected light. How I can draw the reflected light? I just draw the normal line, yes? This is a normal line, and normal line here is going to be exactly the same thing. So the reflected light, I will use a red color. This will be reflected back, yes? So if I want to draw, let's say if this is at 20 degree, the reflected one should be 20 degree as well. Good? We have a tools. You can use these tools, okay, to find the angle of incident and then draw the angle of reflection. Okay? So again, you see, the reflected light may never reach in front of the mirror. What we do, we just extend. Good? Extend the reflected. It should be exactly the straight line. So here, if I draw this straight line, it is not exactly a straight line. So I need to draw, let me just, if, good, this is a reflected. If you extend, you will have this intersection. What is this intersection? This intersection is image of this arrow, yes? Good. So you can do the same thing for the other part, but it's not necessary. If you find the first, okay, so it's gonna be exactly the same. This is how the object is created in the plane mirror, by extending the reflected light behind the mirror. So we will have image. We call this image virtual image. Why it's virtual? Because it's created behind the mirror. Because it's created by extending the reflected light behind the mirror. Okay? Because we are using a virtual reflected light. Good? That's why we call it virtual image. So any image which is created behind the mirror is going to be the virtual image. That's why we can see it. But there will be some images that will be created in front of the mirror. We will talk about those. Okay, just letting you know that when we have a plane mirror, if you stand in front of the plane mirror, good? So your image is gonna be exactly, let's say your length is, okay, your height is 1 meter. What is your image height in the plane mirror? 1 meter. So the plane mirror doesn't change the shape, yes? Okay, it's gonna be exactly the same size. If you are 2 meter and you are standing in front of the plane mirror, your image size or height is gonna be exactly 2 meter. So one other thing, the distance from the object to the mirror, if you call it P, this distance is gonna be equal to the distance of image to the mirror. Okay, so this will be P as well. So if you are standing in front of the plane mirror, this one is not exactly equal. So again, you need to just use the tools to be able to draw a perfect image. Okay? So, but you should know that if you have an image in front of the plane mirror, the distance from the object to the mirror is equal to the distance from the image to the object. Good? So, like this. Okay, this is a plane mirror, and then you have an object. You will have the same size of image here. If this is P, this will be P as 1. So, same size, virtual image. Why is virtual? Because it's created by the extension of the virtual reflected light, and then same distance. What does it mean? Distance from image to mirror is equal to distance from object to mirror. Okay? So this is going to be the plane. Okay. Next thing that is important is gonna be a concave and convex mirror. So we will be using the same rule for convex and concave mirror, but we need to extend the law of reflection when we are analyzing a concave and convex mirror. You see here we have two mirrors, concave and convex. So how the concave and convex mirror are created? So instead of having a plane mirror, we will have a curved mirror. Good. So we will call them convex or concave mirror. So in a plane mirror, the size of image is equal to the size of the object. But in the concave and convex lenses, the size of image, you see this person is standing in front of the curved mirror, and the size of the image, as you can see, is smaller. But here, this person is standing in front of another curved mirror, but the image is appear bigger than its size, the person face, yes? So the image which is created by a convex mirror is always virtual and is closer to the mirror than the actual object. So we call this curved mirror convex mirror. Okay? When the object is close to the concave mirror, this is a concave mirror, the virtual image formed by the concave mirror is larger than the farther. Good? So, but how the image is created in the concave and convex mirror? I'm going to show you how the image is created by using this website. Okay. So, concave mirror. This is a concave mirror. For finding out how the image is created in the concave mirror, so I would like to explain about a couple of rules, okay? Then I will show you these rules here, and you would be able to see how the image is created. Okay, so let me just open new page. You may ask, okay, how the concave mirror is created? Let's say we have a sphere. Good. This is important, okay? Now we are talking about the focal point and central curve. The sphere does have center, yeah? We call this C. We would like to make this sphere a concave mirror. Let's say we have a sphere, a hollow sphere, okay? So, and we would use a material to make good. We use some material and coat this material in the surface area. Good. That's how we can create a concave mirror. So this mirror, as you remember, okay, now we have If we cut this part, we will have this mirror. Good? If I cut this part, yes, then I will have a mirror with the center of curvature. Okay. I call this principal line, T line or principal line. Okay. If I draw the principal line here, this is going to be the principal line. What is the principal line? The principal line will pass from the center and which is perpendicular to the sphere. Good. So the half of distance, again, this is the radius, yes? From this point to this point, we call this radius. Half of radius is going to be the focal point. If you have the center of curvature, okay, which give you the radius, the half of this distance is going to be the focal point. Good? So how the concave mirror is created? The concave mirror is created by the sphere. If we have the inward side of the sphere as a mirror, we will call it concave mirror. The concave mirror does have a center of curvature, principal line, and the focal point. Good? So, rule number 1. If incident light is parallel with principal line, the reflected light pass from focal point. What does it mean? If this is the incident light, and if the incident light is parallel, good, the reflected light pass from the focal point. What does it mean? Let's say we have a concave mirror and we have a light source. This is the center of curvature. This is a focal point, and the light goes parallel. Good? If this light reach to this parallel, what happened? There will be a reflection. Good? So what would be the reflection? The reflection definitely passed from the focal point. Yes? Okay, so let me just draw a little better. So what exactly the concave mirror does? The concave mirror try to converge the reflected light. This is one of the characteristics of the concave mirrors. If you have an incident light, these incident lights are parallel, the reflected light will pass from the focal point. What exactly it does? It does focusing the reflected light. Okay, so back to rule number 1. Okay, these 3 rules that I will mention here will help us to find out how the image will be created. Rule number 2. If incident light pass from focal point, the reflected the reflected light will be parallel with P line or principal line. Good. How can I show the second rule here? I just this was the rule number one, and then I will show rule number two. Okay, let's say if we have an incident light, see, incident light. Okay, what is the reflected light? The reflected light will be parallel. Okay, incident light parallel, reflected light pass from the focal. Incident light, sorry, I draw, my bad. Instead of drawing from the focal, okay. If the incident light pass from the focal, yes, now the reflected light will be parallel. This is going to be number two. Good. If the incident light pass from the focal, the reflected light will be parallel. Good. So it means that if you have a light source and you just change the direction of the light source and all of these light pass from the focal, you would expect to see the reflected light which is parallel to the principal line of the concave mirror. Okay? Rule number three. Rule number, let me just draw rule number three here. Again, concave mirror. Okay, so we have a focal point and center of curvature. Good. Rule number three. If incident light pass from center of curvature, pass from the C, okay, the reflected light pass from the C as well. Why? You remember in the plane mirror, see here? Let me just draw here. In the plane mirror, yes, when the incident light was exactly in the direction of the normal, what would be the reflected one? Okay, so we said that the center of curvature, yes, is the radius, yes? Good. Any line that connects the center to the surface of the sphere is perpendicular. So if I draw these, see this incident line here, it is like one of these points, yes? Because this line is always perpendicular to the surface area, the reflected one is going to be exactly, let me just show with different color. This is going to be the reflected. Three rules we have learned from the concave mirror. Incident light parallel to the principal, reflected one pass from the focal point. Incident light is parallel, is passed from the focal point. The reflected one will pass from the, will be parallel to the principal line, yes? And then the last one, if the incident light is passing from the center of curvature, the reflected light will be passed will be reflected or pass from the center of curvature as well. Good? Three rules. Okay, how we can use these three rules to see how the image is created. Open this page. Okay, what you see here, there is an object here. Good. I can place object anywhere. In the focal point, what is the focal point? The distance from the focus or focal point to the mirror is called the focal area. Okay, focal distance. This is a focal point, and this is the center of curvature that I explained. Yeah. So we have a focal point, and we have a center of curvature. I can place the object anywhere that I would like. This one is the image. How the image look like is in front of the mirror, yes. Whenever the image is created in front of the mirror, it is a real image, not the virtual image. How the image is created? By the intersection of the reflected light. Good. We would like to see how the reflected light will be intersect. We use that three rule or that three light. Incident light. Okay. The incident light you see here. Let me just insert this as a slide. Good. And then go back to here. Now we have this as a slide. Okay. So I would like you to show you these three rules. Again, there are different, you can draw many lights, okay, which is radiating from the object. But I will always draw these three lights. Okay, one is, this is the object. This is the incident light, yes? The incident light is parallel. What is going to be the reflected light? Pass from the focal point. Good? Okay, see? Incident light, the reflected pass from the focal point. What is the other one? What was the rule number 2? If the incident light pass from the focal, the reflected light will be parallel. Okay, you see these two, they intersect. We are done. The point that you see the intersection of the reflected light is the point that shows the image of your object. Good? You can draw the last one as well, but is not necessary. If we use two of these three rules, you would be able to see where the image, how the image and where the image will be created. And the image here, if you place your object in between the focus and the center of curvature, you see the image will be inverted. Good. And it will be real image. Why is real? Because it's created by the intersection of the real reflected light and is bigger. Okay? So I just used the two rules. Okay? So this is how we can explain the image which is created in the concave mirror. Okay? So let me just go back to the website. Okay. So if you place the object at the focal point, what happened? If you know the focal point of this mirror, the concave mirror, if you place the object exactly at the focal point, no image will be created. Why? Incident light, yes. Parallel, the reflected one pass from the focal point, yes. The incident light pass from the center of curvature and the reflected one is going to be exactly the same. Good. If you see the reflected light, okay, they never reach. If you even extend the reflected light, they never reach together. Good? So no image is created. You would not be able to see any image, okay, if you stand at the focal point of the concave mirror. What if I place the object at the focal distance, not the focal point, here? See how the image is created? What is the image right now? It is upright and virtual. Why we call it virtual? Again, use that three law. Okay. Incident light, yes, parallel. See? The reflected light pass from the focal point. Incident light goes pass from the center of curvature, and the reflected one pass from the, you see these two, and you can just draw the third one as well, but it's not necessary. Okay, these two, they never intersect in front of the mirror. Yep. What I do, I extend these two reflected. Yes, I extend this one, I extend the second one. They intersect at one point. You remember the plane mirror? The image is created behind the mirror. That's why it was visual. By extending the reflected one, but because the reflected light, they never intersect in front of the mirror. We extend the reflected light. When we extend, we will see that the image will be created behind the mirror.
What makes it upright?
It is the characteristic of the mirror.
Okay.
Okay, so because we are just trying to draw this part, okay, we will see this part here. That's why it's upright.
Okay.
Good. So just letting you know, whenever you place the object in the concave, in a focal point, see, in a focal point. What is the focal point? The distance from the focal distance. Sorry. What is the focal distance? The distance that between the focal point and the center of the mirror. Yep. If you place this object anywhere here, the image is always upright, virtual, and bigger. But if you place the object in the focal point, no image. If you place the object between the focal point and the center of curvature, the image is inverted. Real. Why is real? Because it's created by the intersection of the reflected light in front of the mirror. Good. And the object, the image is bigger than object. But if you place the object at center of curvature, you see the object is still inverted, but the image is exactly at the same size of the object. Good. How again? We just use these laws. Okay. These three laws that I explained. Good. So if you place the object, you need to practice this. You have this website, you just keep practicing, just learn those three rules, and then have this website open. Just place the object in the focal point, in the focal distance between the focal point and the center of curvature, at the center of curvature, and then behind the center of curvature. Okay, now you see, if you place the object behind the center of curvature, the image is still inverted. The image is still inverted, it's smaller, okay? And it is still real image. Okay? So this was the concave mirror. In the concave mirror, we have virtual image and real image. What is the real image? The real image is created in front of the mirror. Virtual image is created, behind the mirror. That's why we can see the virtual image. But by eye, you cannot see the real image. You need to have a screen here because the image is created in front of the mirror. You cannot see the in front of the mirror. You see behind the mirror, yes? Good. So if you want to see this image, you need to put a screen, something to be able to see it. So the convex mirror is going to be exactly the same thing. So I don't write the rule. I will show the rules here. It's going to be exactly the same thing. But let me just draw. So again, now we would like to explain the convex mirror. I just draw the same sphere. Again, center of curvature, focal point, yes. This is a principal line. Good. Good. Instead of coating that reflective, that material that make the mirror reflective, yes, instead of coating in the surface area, I will coat this material inward. Good. Now you will have this mirror here. Okay, this is a convex mirror. You know, this is a part of the sphere. Yeah, if you just draw the rest, okay, it's gonna be part of the sphere. So if you coat, inside the sphere with that specific material, sometimes can be PB, sometimes can be AG. So you would create a convex mirror. So if I draw the convex mirror, this is going to be the convex mirror. So it does have a center of curvature, it does have focal point, and this is going to be the principal line. Let me just show you the first rule here, okay? So it's going to be the parallel rule. The incident light is parallel. If you draw the reflected light, how you can draw the reflected light? You draw the reflected light, but if you extend the reflected light, okay, the reflected light should pass from the focal. Good? If you draw the reflected light, the extension of the reflected light should pass from the focal. If you have more than one, let me just draw better. This is the incident light is parallel. If you want to draw the reflected one, okay, just draw the dashed line. This is going to be the reflected. What exactly the convex mirror does? The convex mirror will divert the reflected light. So, see here, what would do the concave mirror? The reflected light will be converted, but here in a concave convex mirror, if you have an incident light, parallel incident light, the reflected light will be divergent. This is a characteristic of the convex mirror. Okay? So I will show you the other rules, okay, in here. So if you are again using this website, so if you just move this object and put it in front of the, the mirror changed from concave to convex, okay? This is a simulation. And it makes sense, because the outward is the mirror. Easy to know and memorize the image in the convex mirror. the image, it doesn't matter, is in the focal point, in the focal distance, in the center of curvature, or it's behind the center of curvature, between the focal point and the center of curvature. The image is always upright, virtual image, because it's created behind the mirror, and it is smaller than the object size. Always. It doesn't matter, okay, where you put this. See here? You see? Again, why? Because of that rule. What are the rules? You know, incident light is parallel. Incident light is parallel. The reflected light, if you draw the, let me just draw. Incident light, okay. The incident light pass from the, if you extend the incident light and it pass from the center of curvature, the reflected one is passed from the center of curvature as well. If the incident light, rule number, let's say this was number 1, number 2. If the incident light, if you extend the incident light and it pass from the focal point, the reflected light will be parallel. Good. So incident light, rule number 3, incident light is parallel. So if you are drawing the extended light, good, it passes from the focal. Okay. So this is going to be the 3 rules. But you should know that, you know, the images in the convex mirror always upright, virtual, and a smaller size. Okay. This was the law of reflection.